Okay, so we're going to start our work here looking at determinants and Cramer's rule with the nicest case that we have, the 2 by 2 case. We're going to look at how we can compute the determinant of a 2 by 2 matrix, where determinants are special values associated specifically to square matrices. They don't apply to anything else. One important property that we're not going to talk about too much in this class, but is worth mentioning, is that for a matrix of determinant 0, we will not have an inverse. That is, a way to characterize singular matrices is in terms of their determinant. That is, they have a determinant of 0. But anyway, we're going to focus mostly here on the computational side, where for 2 by 2 matrices, computing the determinant is about as nice as it gets. If we have something of form A, B, C, D, a general 2 by 2 matrix, then when we want to compute its determinant, which we notate det A, or like a matrix but with vertical bars instead, it has the formula AD minus BC. So you can think about this as going across diagonals, kind of like cross multiplying. A little bit. You want to think about some old stuff in that way for how we're approaching this. But what we're going to do now is just take a couple quick examples for some practice with this formula. So we are going to look at computing the determinants of the matrices 1, 4, 2, negative 1, and 2, negative 1, 3, 1, where for these, we're just going to apply that formula pretty much directly. For the determinant in the first case, 1, 4, 2, negative 1, we just multiply across 1 times negative 1 minus 2 times 4, or 4 times 2, however you want to say that, to get negative 9. And in the second case, we multiply across 2 times 1 minus negative 1 times 3 for a total of 5. And when we talk about determinants later in larger terms, we're going to see that we define them recursively. That is, we define them in terms of smaller parts where, unless we have a special pattern we can work with, our goal is always going to be to end up back down here with the 2 by 2 case where we have that nice formula. Technically, we can define formulas for other ones, but this is generally where we're going to end up. Anyway, the next thing we're going to look at is how we can apply determinants to solve systems of equations using what's called Cramer's rule.